Hey guys, coming at you with the goal 1.3 notes today, so go ahead and add that to your table of contents. Follow along in your notebook. Goal 1.3 is going to be all about using the periodic table. We're going to familiarize ourselves with what the periodic table is, what it's there for, and what we can do with it. So our ultimate goal in that A column there, I can identify the name, symbol, atomic number, mass, and group of an element using the periodic table. You are going to need your packet for this as well. So there's a page with a blank periodic table, completely blank one on it, that we're going to use later on in these slides. Let's kind of recap goal 1.2. We learned about the parts of the atom. We have protons and neutrons that are in the middle, what we call the nucleus of the atom, and the electrons are flying around the outside in what we call the electron cloud. And that's useful information because the periodic table is really all about atoms. The different numbers of protons, neutrons, and electrons are different for different types of atoms. Most importantly, the number of protons. The number of protons is going to determine what element the atom is. So we have 118 different types of atoms in the world. That means all the way from an atom with one proton to an atom with 118 protons. We call each individual element or each individual atom an element. You probably know of some elements. Diamonds are made out of the element carbon. You've probably filled a balloon with helium before or played with one. Helium is an element. I'm sure you've used aluminum foil that's made with aluminum, which is also an element. So we're going to kind of dive into what we can find out about these elements on the periodic table. All these elements are highly, highly organized on the periodic table. There's a reason for the odd shape of the periodic table and why it looks like that, which we'll get into more in class with some videos. For now, let's focus on what it tells us. So each square contains information about the element in that square. We have the element name. We have the element symbol. That's going to be one or two letters that represents the name of that element. You have the atomic number. That's an important number for an element. Like I said earlier, the number of protons changes the type of element that it is. So you'll notice that in each square in the periodic table, each element has a different atomic number. That's because each element has a different number of protons. So the atomic number is the number of protons. That's what makes it the element that it is. What makes carbon carbon is that each atom of carbon has 6 protons in its nucleus. That last number down there is when we take the number of protons and add in the number of neutrons in the nucleus, and we call that the atomic mass. So the protons and neutrons are the two particles that create the amount of mass that an atom has. There are different groups on the periodic table. Right now, I just want you to highlight each group or color in each group in a different color and make a key for yourself on that blank copy of the periodic table that you have. In class, we're going to dive more into why the elements are in specific groups and sort of in some of the determining factors that put it into that particular group. So for now, let's just go ahead and everything from lithium down to francium, that column minus hydrogen is what we call the alkali metals. If you need to go ahead and pause the video, do that. Like I said, color that in, shade it in, do whatever you need to do, but make sure you make a key so that you know that whatever color that you're coloring this is called the alkali metals, and then move on when you are ready. The second column there, from beryllium all the way down to radium, is what we call the alkaline earth metals. The large block in the middle of the periodic table is what we call the transition metals. A lot of those you will probably recognize, like titanium and iron and nickel and copper and zinc and silver and gold and platinum. Lots of common metals there. Keep in mind that does not include those two rows at the very bottom. It's just that block on the top, the main part of the periodic table. We're going to skip all the way over to that second to last column. Those are what we call the halogens. Some of those you probably heard of before, like fluorine, chlorine, and iodine. The last column on the very far end are what we call the noble gases. Helium, neon, I'm sure you've heard of those. Maybe even radon, if you've ever bought a new house, or your parents. Um, let's skip to those two rows at the very bottom. That first row, the orange one that you see on my screen, is what we call the lanthanides, named after the first element in that row, lanthanum. And the second row that you see in green, called the actinides, named after that first element there, number 89, actinium. Next group, this is kind of a weird one. We're now switching kind of away from technical groups on the periodic table and more so just different divisions of elements. So we have what's in between metals and nonmetals are some elements that we refer to as metalloids. So be careful when you're making those. You should see what we call the stair step line darkened in on your periodic table, and that's how we sort of divide up the periodic table, and these elements that are touching that line we call the metalloids. To the left and right of the metalloids, we've got some elements that aren't necessarily a part of a specific group, so we refer to them as other metals and other nonmetals. And that's mostly just for this class, so we can still classify those elements into a group. So make sure you're conscious of which elements you are highlighting there. And also don't forget hydrogen. He's way up here in the corner. He doesn't really belong with the alkali metals for various reasons that we'll talk about in class. So we're going to group him together with those other nonmetals that you see in blue over here. So those metalloids were kind of on that stair step line. Everything to the left of that is metals. Everything to the right of that we have nonmetals.